Hi, I'm Charles, and I'll be going over question 3, function fun. This question tests your understanding of big omega, big O, and big theta. So just going over what those are quickly. Recall that big omega describes an asymptotic lower bound. Mathematically, this means a function f of n is in the set big omega of g of n if there exists a constant c such that c times f of n is always greater than g of n after some point. Similarly, big O of g of n describes an asymptotic upper bound. Mathematically, this means a function f of n is in the set big O of g of n if there exists a constant c such that c times f of n is always less than g of n after some point. Lastly, big theta of g of n describes an asymptotic tight bound, meaning the rate of growth is both lower and upper bounded by the function. And you can think of this like big omega and big O combined. So moving on to question 1, we can see that n log n is always less than n squared log n. And so any function upper bounded by n log n would be in this region. And so we can see that any function in here would also be upper bounded by n squared log n. And so the answer is true. For question 2, we're working with big theta, and this means because big theta describes a tight bound, the statement is only true if the two functions differ by a constant factor. And n to the 28th grows much faster than n to the 14th. If you look at the rate at which they differ by in terms of their growth, it's n to the 14th. And this is not a constant, and so the answer is false. For question 3, we're working with big omega, which is a lower bound, and we see that log n is less than n to the 4th plus n cubed plus n squared plus n. And so looking at the graph, there can be functions that are lower bounded by log n, but not lower bounded by n to the 4th plus n cubed plus n squared plus n. For example, like something like this. And so that's clearly a counterexample, and so the answer is false. Lastly, for question 4, we want to select all the functions that are equivalent to big theta of 6 to the n. So as discussed before, this is only true when the two functions differ by a constant factor. And so the easiest way to test this out is to divide each of them by each other and see what that is. So like, for example, the first one, n to the 6th over 6 to the n, there's no way to reduce that, and like it's not by a constant factor, so that's not valid. The second one, 5 to the n over 6 to the n, means they differ by like 5 over 6 to the n, which is not a constant. But the third one, dividing clearly is 3, which is a constant, and so that is a valid answer choice, and we select that. Moving on, choice 4 does not differ by a constant, but then choice 5 does. Like using exponent properties, we can factor out the 6 to the 5th. And so, yeah, it differs by 6 to the 5th, which is a constant. And so we select that. And that's the walkthrough for question 3.